Welcome to this explainer. Today, we're targeting a massively important piece of the CompTIA A Core 1 certification, Domain 2, which is all about networking. My goal by the end of our time together is to help you build a rock-solid mental model of how networks actually operate layer by layer. Whether you're an IT novice or you're already tinkering with tech, we're going to break this down so it just simply makes sense.
So why should you pay close attention? Well, Domain 2 carries some serious weight. It makes up exactly 23% of the entire Core 1 exam. Think about that. Nearly a quarter of your grade is riding on your ability to understand how these devices talk to each other. You definitely cannot wing this section, but don't worry, we're going to conquer it together.
Here is our roadmap for today. First, acing Domain 2. Then, hardware, cables, and tools, followed by the wireless world. After that, protocols and IP addressing, and finally, configuring SOHO networks. All right, Section 1, Acing Domain 2. Just a foundational truth to start us off here. Networking is the literal and figurative backbone of modern IT infrastructure. Every laptop, every server, every smartphone, they're all just isolated islands until you actually connect them. And for the exam, you need to understand not just the what of these connections, but the how and the why. Okay, let's dive into this. Section 2, Hardware, Cables, and Tools. We are starting at the very bottom layer with the physical, tangible foundation of our network architecture. Basically, if you can touch it, plug it in, or crimp it, it lives right here. On the exam, you're going to be heavily tested on physical components. You've really got to know your cables. We're talking Ethernet categories like Cat5e and Cat6 for your standard networking, fiber optic for high speed, long-distance data, and of course coaxial for broadband. You also need to know the tools of the trade. You're going to use crimpers to attach RJ45 connectors to Ethernet cables, cable testers to ensure those connections are solid, loopback plugs to test your physical network ports, and Wi-Fi analyzers to map out wireless signals. Speaking of cables, there is a highly specific exam hook you absolutely must know. Have you ever looked up at an office building's drop ceiling? That empty space above the ceiling tiles is actually often part of the building's air circulation system. If you run network cables up there, they legally must be plenum rated. And why is that? Because standard cable jackets, if they catch fire, release incredibly toxic gases. Plenum rated cables are fire resistant and stop those toxic fumes from circulating through the building's air supply. It's an absolutely critical safety standard. Now, as we move from cables to hardware devices, keep this vivid analogy in mind to help you understand how different devices handle your data. An outdated network hub, it's like a public broadcast speaker. It receives data and just lazily blasts it out to every single device in the room. It's noisy, it's inefficient. On the exact opposite end of the spectrum, a network firewall is a fortress guard. It meticulously inspects the source, the destination, and the content of every single data packet, tightly controlling traffic to protect your network. Another physical hardware concept you're going to see a lot is the acronym PoE, which stands for Power over Ethernet. Let's de-jargonize this a bit. Imagine you're mounting a security camera way up on a high ceiling. Running a totally separate power outlet up there? Yeah, that's expensive and super annoying. PoE solves this brilliantly. With a PoE-enabled switch, a single Ethernet cable delivers both your high-speed network data and the electrical power needed to turn the device on. It's absolutely perfect for cameras and wireless access points. Moving right along to Section 3, the wireless world. Now that we've mastered the physical cables, we transition up into the invisible wireless space of our network architecture. Now, what's really interesting about this slide is tracking the massive evolution of Wi-Fi. It's fascinating. For the exam, you have to know your 802.11 standards. We started out with older standards like A, B, and G, eventually moved up to N and AC, and now we're rocking Wi-Fi 6, which is technically known as 802.11ax. With each leap forward, we get significantly faster data speeds and the incredible ability to support way more devices simultaneously without the whole network just grinding to a halt. Within those Wi-Fi standards, you have to choose your frequency band, and there is a very direct trade-off here. The 2.4 gigahertz band is kind of like a marathon runner. It's a bit slower, but it has fantastic endurance, meaning it easily pushes its signal through physical obstacles like walls and heavy furniture. The 5 gigahertz band? That's your sprinter. It gives you blazing fast speeds, but its range is shorter and it gets blocked pretty easily by those same physical barriers. But wireless isn't just about internet routers, right? You also need to understand short-range connections.
Bluetooth is a classic example. It pairs your personal devices together like your phone and your wireless headphones, creating what we call a personal area network, or a PAN. Then there's NFC, or Near Field Communication. This is for extreme short-range data exchange. If you've ever held your smartphone just inches away from a register to use Apple Pay or Google Wallet, you are utilizing NFC.
Section 4, Protocols and IP Addressing. We're stepping up another level here into the logical software layer of the network. This is where we finally unpack all those acronyms that define the actual rules of digital communication.
First up are our transport protocols, TCP and UDP. Think of TCP as sending a certified package in the mail. It is connection-oriented, it tracks the data, it checks for errors, and it requires a receipt confirming the data was delivered reliably. UDP, on the other hand, is literally like throwing a huge stack of postcards in the mail. It's connectionless, and it doesn't wait around for receipts. Because it skips those quality checks, UDP is incredibly fast, but it relies on best effort delivery, meaning some of that data might get lost along the way.
And this brilliantly illustrates how the network caters to humans. DNS, or the Domain Name System, operates on port 53. Now, computers only understand numbers, specifically IP addresses. But you and I, we don't want to type in a string of random numbers every time we go to a website. DNS acts as the internet's phone book. When you type in a domain name, DNS seamlessly translates that text into the correct numerical IP address, totally behind the scenes, so the server can connect.
Another vital automated protocol you gotta know is DHCP. When you connect your laptop to a network, you're not manually typing in your IP address. DHCP hands you a lease for an IP address automatically. However, as an IT tech, you might sometimes use a DHCP reservation. This is a neat setting where you tell the server to ensure a specific device, like, say, a shared network office printer, always gets the exact same IP address every single time, so users never lose their connection to it. All right, time to test your troubleshooting skills with a classic scenario you are highly likely to see as a performance-based question on the exam. Imagine you're working the help desk. A user calls and says they can't get online. You check their system, and you notice their IP address starts with 169.254. So what exactly just happened? The answer is APIPA, or Automatic Private IP Addressing. When you see an address starting with 169.254, it means the computer cried out to the DHCP server for a valid IP address, but the server just never responded. So the computer gave up and assigned an APIP address to itself. This immediately tells you there's a communication failure on the network, and rebooting the router or that DHCP server might just be your very next step. Let's move to Section 5, Configuring SOHO Networks, and see how this all builds together. This is where we combine all of our physical, wireless, and logical knowledge to configure a small office or home office network. When you're setting up a network, you first need to identify its scope. A LAN, or local area network, is confined to a single building, like your house or a small office space. A PAN, as we discussed earlier, is your personal Bluetooth bubble. But what if you need to connect buildings across an entire city or even across the globe? Well, that requires a WAN, or wide area network. In fact, the internet itself is just the world's largest WAN. Now, here is a huge pitfall you want to avoid when you're setting up multiple workstations in your SOHO environment: the dreaded IP conflict. You should never manually assign the exact same IP address to two different computers on the same network. If you do, those machines will essentially fight each other, constantly kicking each other offline, and neither one of them will have reliable access to the network. So how does a technician actually bring a SOHO network online? It's a logical flow. Step 1, connect your physical media, plug in your modem and your router. Step 2, configure your logical layer by setting up DHCP to automatically hand out those IP addresses. Step 3, set up your Wi-Fi access and immediately lock it down with modern WPA3 wireless security. And finally, step 4, if your client needs to, say, access an internal security camera from outside the office, you jump into the router and configure port forwarding to intentionally allow that specific outside traffic in. And that is Domain 2 in a nutshell. Since networking truly connects every single piece of modern IT infrastructure, the real question is, which layer of this architecture are you going to hit the books and master first? Will you start with the physical cables, or are you going to dive deep into troubleshooting those APIPA addresses? The choice is totally yours, so get out there, practice your troubleshooting scenarios, and absolutely crush that Core 1 exam. Thanks for joining me on this explainer.